Welcome to the third day of doing Advent of Code. So today's problem, we just read it first. So there is an L, batteries. So we have batteries, a supply of batteries that is there, and in this supply of battery, we have to choose two battery from every bank. So this is a bank, this is a bank, this is a bank, this is a bank, and this is a bank. From every bank we have to choose two numbers such that if we choose those numbers we'll get largest possible voltage from them. So from this array we'll have to choose it. This is the part 1. So part 1 is pretty easy. So the first method that you can do is just by brute forcing it or having a 2-pointer. The second is keeping track of two max numbers, because here the largest possible will be made using the two max numbers only. And the third, and this should be the optimum one, will be swapping the numbers. For two numbers, the optimum will be max and second max. This will be the most optimum because this goes in O of n. When swapping the numbers, this will go, according to me, as n into the length. Suppose it is 2, then 2. If it is higher, then higher. So this also finally takes O of n only, depending on the length of the string that you have, the number of batteries that we are going to select. So the first one is easy. First one with max and second max, we can do it. The second one will be a problem if we go using this, because in the second one we have 12 digits, and for 12 digits we cannot have max, second max, third max, and so on. That is not possible. So what should be the approach? So see, one of the approach, this is what I had thought before, but this was okay because we have just 2 points, and now for 12 points it won't be feasible. So what if we find the max element from the last necessary elements? What if we find the max element from the last and excluding the necessary elements from the start? Excluding the necessary elements means if we have 12 numbers in the start, we'll not include them, and suppose we have 10 remaining, then first and second last two we'll have to leave, and the first 10 we'll choose. That is what I was thinking. But this approach also went wrong when I tried some examples with it, because the first middle element could be the lowest and the initial elements would be the highest. That is what was wrong. So now the final one, the proper approach that then what I used was Now just think of it as this way. This is an array, suppose of 100 numbers that we have. Alright, 100 digits. We do know that we need to find the 12 number array. So the last 12 digits can be taken. Now suppose we have those last 12 digits and this is completely filled. Now we have a number A. Now A is greater than the first element. Let's take first element, 0th element. Is greater than the 0th element. Now what we do is we swap. So whatever the 0th element was, suppose P. So P is our element and now A. Then we will increment. Increment as in P, after P comes Q. Q is our first element. So the first element will be A and the second element will be Q. Now P is compared to Q. If P is greater than Q, then the same step happens. We swap the elements. And if P is less than Q, we break from the loop. Getting? I'll repeat this again. This logic takes some time. So for swapping, suppose this is the number array. Here we had the first 12 elements. After that we have A, B, C, D, E, F, and here we have P, Q, R, S, T, U. Now first A is compared with P. If A is less than P, then the loop stops. If A is greater than P, then the array changes to A, Q, R, S, T, U. And now P is compared with Q. Now P is less than Q, it stops. If P is greater than Q, then the swap happens. Alright, we'll have A, P, R, S, T, U. Now let's think. This is the key is less than Q is less than R. Let's take it as an assumption now. Now what will happen? So A and P's comparison is done. Which is the next element now? B. So B and A will be compared now. If it is less, B is less than A, now C will be compared with A. If C is greater than A, now we will swap the elements. A, then P, R, S, T, U. Now we know that we had swapped A was greater than P. Now again A, P, R, S, T, U. Again V, F, P, S, T, U, and so on. This goes on. So the worst case scenario would be, let's take this. These were 100 elements and this was 12 elements. So n O of n into O of n into 12 into the number of lines. Let's go through the code. So this code you can go through the repo that I have, advent of code 25 day 3. So here you can see we are computing. So let's start from here first. So part 1, part 2, 0, we are reading the input. We are getting the input in a list form over here, list of numbers, a single line. This is a single line. So the file will be list of lines like this. And then we are making a duplicate with it. After that we are computing for 2 and we are computing for 12. Over here what we do is, so here we have suppose the last 12 or 2 elements. Now this is the loop on number and this is the loop of the inner array, the array with PQRS or the final array, number array. Here what we do is we swap the numbers, and here we break. And finally, to get the output, we just compute the sum and then add it to part 1 and part 2, and this way we will get. So the final algorithm would be, first pass the input by default, then populate the array, the answer array. Let's tell it the answer array. Check if the next element in the num array is greater. If the element in the num array is greater than the element in the answer array from the start. Third, if equal, then swap the two elements and increment the answer array. If not equal, then break the answer array loop and take the next num element. So this would be the algo, and then we add to the some part, and the last we display. Alright, that's all for advent of code part 3, day 3, part 1, part 2. Good question. Alright, thank you.